So this question here is an interesting one because you have to process the information they give you in the right way. So you can see this is an ion and it has a 2 minus charge already. And it says that it has 54 electrons. So the fact it's got 54 electrons and it's got a 2 minus charge must mean that it had 52 protons originally. Because if you had 52 protons and you now got 54 electrons, you would have a negative 2 charge. So the number of protons is 52. And then to work out the neutrons, all you have to do there is the 125 and we take away the 52. And when you do that, you get an answer of 73. 1 mark for each one. Okay, next one. A sample of silicon contains isotopes. State in terms of subatomic particles how these atoms are the same. So what they will have that is the same is the same number of protons. Okay, the next one is calculate the relative atomic mass given that it's an isotope and we've got 3 isotopes here. So let's just put down that we're trying to calculate the relative atomic mass. And to do that, what we do is we take the mass of the first isotope, which is 28, and we multiply it by the percentage of that isotope. So we times it by 92. And we do the same, put brackets around that minute, we do the same for the second one. So the mass is 29. I'm going to multiply it by the percentage, which is 5. And then the final one, we've got a mass of 30, and we're going to times it by 3. We do that. We then have to divide all that by 100. So plug that into a calculator. It's given me an answer of 28.11 as a final answer. And if we just check that, because 92% had a mass of 28, so we'd expect our answer to be nearer to 28, and that is, so that's going to be the correct answer. Okay, next one is a 6 marker. What's useful here is to break this down to help you approach it. So we've got 3 substances, and it says deduce the structure and the bonding of each substance, explain their properties in terms of structure. Okay, so there's kind of 3 parts to do for each substance in the table. Okay, so I've done this one at a time. So let's go through what I've written. So substance A, the fact it does not conduct as a solid, but it does conduct when molten, suggests that this is ionic. And that would mean that it doesn't conduct here as a solid because the ions are held in a lattice and they are not free to move. It will conduct when molten because the lattice is broken, so those electrostatic attractions are broken, and that means the ions are free to move. Melting point is high, and the reason the melting point is high is because there are strong electrostatic attractions between the ions and they need a lot of energy to break. So therefore this structure is an ionic compound. Each of these marks here is 1 mark towards the total points for this question. Okay, part B, let's have a look at B. So B here says it's a good conductor when it is a solid, and it's also a good conductor when it's molten. So that makes me think that the fact it's a good conductor when solid and molten means that it contains delocalized electrons, and they are free to move in both a solid state and the molten states. It also has a high melting point, which suggests that the attractions in there are strong. So there are strong electrostatic attractions between the metal cations and localized electrons, and these need a lot of energy to break. So this one is a metallic or metal structure. And the final one, I reckon the final one's a simple covalent. If I just come up to show you why. So simple covalent, let's look at these conditions first. So it's a poor conductor in solid and molten state. And the reason that is the case is because there aren't any delocalized electrons, and therefore there's nothing free to move. So it's not able to conduct electricity. The melting point was quite low, and the reason that simple covalent have low melting points is because there are weak forces between the molecules, and these do not require a lot of energy to break. Definitely simple covalent structure. So if you count the red marks up, I make it there's a total of 16. And again, to help you apply marks to this, if you've got more than 14, give yourself a 6, and so on and so on and so on as you go down the list.